wrapping up 823. It says in the lesson you will apply your skills with exponential functions to a system of equations as you explore the value of cars in an investigation. So fast cars. The moment you drive a new car off the dealer's lot, the car is worth less than what you paid for it. This phenomenon is called depreciation, which means that as time goes by, the car is worth less and less. Some cars depreciate more than others, that is, they depreciate at different rates, but most cars depreciate over time. On the other hand, some older cars actually increase in value over time. This is called appreciation. Geraldine had a choice between buying a new Concorde EX for $27,000, a used Escalade that would have been $70,000 new if bought last year, or a 1967 Mustang for $18,150. Consumer Car Resource reports that the value of the Concorde depreciates at 6% per year. The Escalade will be worth $28,670 3 years from now. It also reports that the appreciation of the Mustang has been historically very consistent, and it expects the trend to continue, and it gives us this table. So it says investigate the value of each of the three cars over time, generate multiple representations of the value of each car over time, and decide whether Geraldine should buy and defend your choice in as many ways as you can. So I think the idea is this. They give you some further guidance if you want some help to kind of go through there, and I don't think it's a bad idea to look through that if you get a little bit stuck. However, I feel like I can tackle this without that, although, pride goeth before a fall, so we'll see how I do here. So let's tackle these cars one at a time. So first of all, let's go with the Concorde. So I want as much room as I can for myself. So the Concorde EX. It says a new Concorde for $27,000. And I'm ignoring all the stuff until I get to the Concorde again. It thinks it's slick, kind of trick us by throwing this stuff all around. But the Concorde depreciates at 6% a year. So pretty easy. They're pretty much just giving me this equation. I start at $27,000. I lose 6% a year. That means I keep 94%. So 0.94. That's going to be the equation of the Concorde. I can answer questions off that later, but I go straight to the equation there. I feel pretty good about that. Next one they talk about is the Escalade. And the Escalade says would have been $70,000 if bought last year, new last year. And it will be worth $28,000 3 years from now. So -1 a year ago, it was $70,000. We don't know what it's worth right now, but we know in 3 years it'll be worth $28,672. So had a choice between buying a new Concorde, a used Escalade that would have been $70,000 if bought new last year, and that it will be worth this much in 3 years. So 1B, 2Bs, 3Bs, 4Bs. So 70,000 times b to the fourth should equal 28,672 divided by 70,000. B to the fourth is going to equal, we'll go ahead over here and we will say it is 28,672 divided by 70,000. And we're going to get 0.4096. And obviously I need the fourth root of both of these. That's a 4 right there. So I'll take the fourth root of 0.4096, and that will give me B. So fourth root of 0.4096. Sometimes it just doesn't want to register, and I don't know why. I guess I got to close it again. So we'll go fourth root of 0.40. Man, I'm really struggling right now. Made a lot of videos today. So B is going to equal 0.8. So that means that I can grab my calculator and just start multiplying by 0.8, right? So 70,000 times 0.8, I believe will give me 56,000. So there we go. My zero term is 56,000 times 0.8 will give me 44,800. Essentially, I already know this. I just want to see if I land on 28,672. So I'll multiply again. That will give me year 2. And then I'll multiply again. This will give me year 3. And I'm really hoping that I get 28,672 here. And I do. So I can go ahead and assume that my zero term is 56,000. So that's what it's worth right now. So my escalate will have the equation y equals 56,000 times 0.8 to the x. So you can already see we're making a decision between these two cars. It's clear that the Escalade is losing 20% a year, whereas the Concorde is only losing 6% a year. So if you want something that holds its value, first of all, you're paying half as much for the Concorde, and it holds its value better than the Escalade does. So I don't know how accurate all this is, but I will say I think SUVs lose their value quickly, which is why I bought a used SUV. So I let somebody else take all the depreciation, then I swooped in and bought it for cheap, because I am cheap. All right, so next we have the Tustang. It's 18,150 now. So what's that multiplier, right? I know that 15 times something equals 16.5. So 15,000, so this is the Tustang, or the Mustang as it were. So 15,000 times something equals 16,500. I'll divide both sides by 15,000 to get my B. So B is going to equal 16,500. So I guess I'll just turn this off and back on. It's a pain to get to where I want to be here. Oh, I'll be darned. Okay, so 16,500 divided by 15,000. I get 1.1. So this one's actually increasing 10% a year. So if I multiply by 1.1, 15,000 times 1.1, I should get 16.5, which I do, times 1.1, I should get 18,150, which I do. So there we go. We get, the Tustang has the equation y equals 18,150 times 1.1 to the x. So I think there you go. It's the cheapest car and it appreciates in value, the Tustang. It's the one I would buy. Plus, you got to drag a bunch of kids around here. No one wants to do that. I think that's like a family car. Maybe okay, but Tustang, way cooler, cheaper, and it appreciates in value. I feel like that's the way to go for the win. All right, so continuing along here. And by the way, obviously you could have done graphs of those and all that good stuff. I chose to skip that and just go straight with the equation. At this point, well, we did tables too, though, on some of those, so that was good. This, again, here was further guidance to help you kind of come up with those conclusions. So now we can go to 817, the Penny Lab. It says, as you saw in the Penny Lab, half-life applies to situations other than radioactive decay. In fact, the idea can be applied to anything depreciating or decaying exponentially. So from the values of fast cars, estimate the half-life of the Concorde. Well, it was losing 6% a year. I do remember that. So I think the equation was 27,000 times 0.94 to the x. Well, what's the x have to be for the y? Well, half-life means this would be worth approximately 13,500, right? So I got an x there. So let's divide both by 27,000. And we're going to get 0.5 equals 0.94 to the x. So essentially, what does this exponent have to be to get this to equal 0.5? So it's known as logs. You're going to learn about this your junior year. We're just going to kind of guess. So we're going to say 0.94 to the 5th power. That doesn't get us there. So 0.94 to the 10th power. And again, we're sort of guessing and check this, but your junior year, you'll learn about logs. You'll learn how to solve this. So the 10th year, I'm getting pretty close. So we'll say 0.94 to the 11th power. I'm real close there. So it looks like sometime during the 11th year. Let's just plug 12 in to make sure that we get something like 0.49 or something. 0.47. So we do so somewhere between the 11th and 12th year. So your half-life is about 11 years. So we'll put about 11 years. According to the mathematical model, when will each car have no value? Never, right? The concept of an asymptote, it's always going to have at least a little value. It'll never get to zero in theory. And then finally, to wrap up Chapter 8, mercifully, I made all these Chapter 8 videos in one day. I am clearly getting wonky, and I am definitely ready to be done. Plus, coronavirus is sort of over. We sort of skipped these chapters. So if anyone watches these videos, most likely it will be in the future a kid who's absent or something. So I'm not going to get a lot of bang for my buck on these videos. Anywho, in 2011, a brand new SUV cost $35,000 to drive off the lot. In 2014, the same SUV is valued at $22,500. So again, we'll just say year zero, it was $35,000. Again, realizing that year zero is actually 2011, right? So 2012 would be year one, 13 would be year two, and 14 would be year three. In year 14, we know that it's worth $22,500. So what's the depreciation here? Well, we have 1, 2, 3 B's, so 35,000 B to the third equals 22,500. We divide by 35,000, and then we take the cube root of whatever we get. So let's go ahead and take this calculator. We're going to say 22,500 divided by 35,000, right? And we'll take the cube root of that. So I will say the cube root of the answer, it'll just be easier to put answer in here, equals, that way I don't have to type 0.64, it'll just use the last answer, and I get 0.863. Again, that's what I'm keeping. If I'm keeping 86%, that means I'm losing about 14%. Again, because that multiplier 0.86 means that's what I'm keeping. And then I think this is all homework, so I'm going to call it a day there. Have a good one.